Okay, in this video, we're going to be talking about adding fractions with unlike denominators. Remember, denominators are the bottom numbers. When you have two fractions that you're going to add, sometimes those bottom numbers are the same, sometimes they're not. When they are the same, it's pretty easy. When they're not, it's still not that difficult. A little trickier, but you can get through it. Here's an example of what I'm talking about. Excuse me. I've got two fractions where the bottom numbers or the denominators are different, 5 and 10. First step I'm always going to do, I'm going to see if the larger denominator is in the smaller denominator's times table. In other words, is 10 in the 5 times table? Well, let's see. 5, 10. Bingo, there it is. That was easy. That being the case, look what I do. I'm going to put an equal sign on for both fractions. I'm going to copy that 10 on both sides. Okay? There we go. Next step is even easier. I look for the set where the denominators are the same now. Here's a 5, here's a 10. Not the same. Oh, but look, here's a 10, and here's a 10. What does that mean? Well, notice the equal sign. If 10 is equal to 10, then this is a 3, so this also has to be a what? A 3. That was easy. Okay? You always start with the easier one, where the bottoms match. Now, in this case, this is a little bit trickier, but not really. Remember, there's an equal sign. So whatever I do to this, I got to do to this. I ask myself, what do I multiply by 5 to get 10? 5. 2, right? So look what I do. I put a little times 2 in between. I take that times 2, because remember, 5 times 2 is 10. I take that times 2. I also copy it up here. Remember, what I do here, I got to do here to make it equal. Remember, fractions don't have to be the same exact name or have the same exact numbers to be equal. It's like if your name is Robert and they call you Bob. Okay? You're still the same person, you're just being called something different. Same thing here. 5 times 2 is 10. What's 2 times 2? 4. In other words, 2/5 is the same as 4/10. It's just a different way to cut it up. That's all. So now, you'll notice both my fractions, I can get rid of this now, both my fractions have the same denominator. Now I'm good to go. Now I'm going to add. My final answer is coming. The denominator stays the same, 10. Now I add my tops, or my numerators. 4 plus 3 is what? 7. And there's my answer. 7 over 10. If it was too fast, remember, you could always pause it, rewind it, play it back, take notes, whatever you got to do. But there you go. Okay? Now that's one way. That's when the larger denominator is in the smaller denominator's times table. But sometimes it's not that easy. And for this one, I'm going to flip the board horizontally, and you'll see why in a minute. Let's try, if I can do this one. Remember, feel free, like I said, to replay. Similar situation, two fractions where the denominators are different. First step I did last time, larger number or larger denominator, is that in the smaller denominator's times table? Is 8 in the 3 times table? 3, 6, 9. No, it's not. 3, 6, 9 already skipped it, so that can't be right. It's going to be a little trickier, but it's still very much solvable. Okay? Or soluble, either way. So here's what we're going to do. We're going to focus on the denominators, 3 and 8. We're going to focus on their times tables. This is where you really would be so helped if you knew all your times tables. Make life so much easier. So up here, I'm going to put the 3 and the 8. Now I'm going to write down their times tables. And I'll let you know when I'm stopping. See if you can catch on what I'm doing. 3, 6, 8, 16. 3, 6, 9. 8, 16, 24. Notice I'm alternating. 3, 6, 9, 12. 8, 16, 24, 32. 3, 6, 9, 12, 15. 8, 16, 24, 32, 40. 3, 6, 9, 12, 15, 18. 8, 16, 24, 32, 40, 48. Now, I bet you're saying, what are you doing? Well, what I'm trying to do is I'm trying to look for a match where both times tables have at least one number or that's the same in both. Notice so far I have no matches. So I'm going to keep going until I find that match. 3, 6, 9, 12, 15, 18, 21. 8, 6, 20, 8, 16, 24, 32, 40, 48, 56. 3, 6, 9, 12, 15, 18, 21, 24, 8, 16, 24. What do you know? Finally, we found a match. Both times tables have a 24. Once I find that first number that both have in common, I'm good. I stop. That is called the least common factor. It's the smallest factor that both have in common. Least common factor, or LCF. So now that I know 24 is it, that's going to be my denominator for both. 24. Did I say factor? Shame on me. Multiple. Least common multiple. Sorry about that. Anyway, long day. So both fractions are going to have a 24 as the denominator. Now, what do I do now? Well, I skipped that easy step from the first example. Now I have to decide what I do to each of the originals to get the 24. So what do you do to 3 to get 24? What do you multiply by 3 to get 24? Of course, you multiply 8 or by 8, right? So now I'm going to copy that times 8 up here. 3 times 8 is 24. 1 times 8 is 8. So the top's going to be 8 over 24. What do you multiply by 8 to get 24? 3, right? So I copy that times 3 up here. 3 times 3 is what? 9. There we go. So instead of dealing with this, I deal with 8 24ths plus 9 24ths. I don't need this either because I just wrote it here. This is the new problem. This turned into this after all that work. Now I just add. The denominators are the same, so the bottom is going to stay the same. Just add the top, the numerators. 8 plus 9 is what? 17. And that is my answer. Because 24 was where I had to be to get them both in common, that's the best I could do. All right? So now you've got an example of both the easier ones where, the larger denominators and the smaller denominators times table. And you've also got one where it's not so easy. And you have to look for the least common multiple. And once you do that, you do the same, pretty much the same steps, skipping a couple here and there. All right? I hope you found that helpful. Remember, you could always go back, take notes, pause, review it, replay it, whatever you got to do. Do it in little steps. You'll get it. All right? Thanks.